Hey guys, today's video will focus on dividing decimals, but we're going to use models to solve. Let's go ahead and get started. Aiden used base 10 blocks to represent a division problem. Write an equation that represents Aiden's model. Keep in mind that an equation just means two equivalent expressions, and it does require having an equal sign. So we have to first figure out, what did he start with? Well, he started it off with 2.5 or 2 5/10, and then we're dividing by 5, and this is how I got the 5. These are my 5 groups, and we have to figure out what is in each group. And so on the first group, which is all of each group is equivalent, 2 rows are actually included, so that would be 2/10, because you have to keep in mind it's 20 out of 100, which would be equivalent to 2 out of 10, or 2/10. For the next one, we're in the same position where it's 2/10. And the last one, it's 10 out of 100, which is equivalent to 1/10, which is definitely why it's important to understand equivalent fractions. I do have videos on equivalent fractions, so you might want to check them out if you need review on that. And each group is 5/10, because what I did is I added 2/10 plus 2/10 plus 1/10. If you wanted to check it, you could just go 5/10 times 5, and you end up with 2.5, or you could just add it 5 times. All right, so for the next one, Riley used an area model to represent division problem. Write an equation that represents Riley's model. So you're used to multiplying. This is typically what you multiply, the 3, and then be 6 3/10, but we decompose 6 3/10, and then your solution or your total is 18 9/10. Since we're representing a division problem, it's going to be looking like this. This is your total, 18 9/10, and then you're dividing it by 3 groups, and in each group is 6 3/10. So let's keep going. Esau used a number line to represent a division problem. Write an equation that represents his model. So the first thing I want you to look at is the number line. And I'm going to present it in a way that I really feel like it makes more sense to kids. So in the first one, it's 500ths. And for some reason, kids need to see the same amount of, and I understand, the same amount of numbers. And so here you have 500ths, and here you have 1/10. And so it's easier for students, in my experience, to just go ahead and have the same amount of numbers. So 1500ths is fine. This becomes 2000ths, 3000ths, 4000ths. Now you want to look at it as coins: 5 cents, 10 cents, 15 cents, 20 cents, 25, so forth. So if we're looking at it like that, from 35 to 40, you have 5 spaces. So what that means, this must be 36. So we're starting with 3600ths. And then if you count your groups, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 groups. And in each group, they are equivalent. So if you want, we can just look at the first group, which is easier. It stops right here, which would be 400ths, or if you want to look at it as money, 4 cents. So our solution would be 400ths. Hope this video helped. I will also be making some videos without models, so don't forget to hit like and subscribe.